Hey guys, we're CE Rocketry, and in this video we're going to be talking about Double Fillet, our rocket test bed for our homemade engines.
Double Fillet was developed to be launched off of our homemade rocket engines that we have been working on the past few months.
So this rocket has three main parts: the nose cone and the body tube, which are just rocketry parts that like most model rocketry kits have. So like plastic nose cone and then like cardboard body tube. And then the fins are actually 3D printed, and along with a lower section of fuselage at the bottom. And that is mainly so that like the fins would be perfectly straight, and that also it was a lot easier to design it that way so that our engines fit in it.
So this motor mount and fin section was designed in Fusion 360. We had to do this because, as Ethan mentioned before, the homemade motors that we made don't match any commercial motor size, and so common motor mounts that you can buy wouldn't fit correctly. And so by 3D printing the motor section, we were able to get a perfect fit between our engines and the rocket.
So you might be thinking, where does the name come from? And the name actually comes from, so in Fusion 360 or like other CAD programs, there's a tool called the Fillet tool, which basically you use to curve edges to get them like rounded. And so that tool was used to like curve the leading edge of the fins so that it's more aerodynamic. But whenever designing it, one of the fins just like wouldn't curve for some reason, and we're not CAD pros, but I mean it should have worked anyway. But yeah, so it kind of like showed that it was curved, but it wasn't actually curved. But then just like applying the fillet tool again to it just made it curved, so double fillet.
Because we did it twice. So we have done 2 test launches so far with Double Fillet. They were both done using commercial Estes rocket engines. This is done because it removes a variable, and that we are just testing the rocket instead of both the rocket and one of our motors. And it allowed for a little more consistency in the thrust that we were going to output and the ejection charge and that sort of thing. To do this, we had to design an adapter that would fit the Estes engines to our rocket, because as we mentioned before, that was designed for our homemade engines using PVC pipe. And so Ethan here just drew this up in CAD real quick, printed it out, and it fits the motor right in. And then we just put this inside the rocket, and it worked perfectly for the test launches.
So our first test launch was on a C65 from Estes, and that launch was somewhat successful. Right after it lifted off the pad, it began to pitch over quite a bit, and so it didn't go super high, but it landed quite a distance away from our pad despite that lack of height. So what we think that was due to the nose cone, there's some clay, because since the fins are 3D printed, they're quite a bit heavier than normal fins, so we had to put quite a bit of clay on the top to balance it out. And so we think that the clay wasn't perfectly like set so that it wasn't like even across it, so that might have caused the weight to lean over it a little bit and caused it to pitch over. And also the ejection charge took quite a bit, since it was 5 seconds and it didn't go super high. It was kind of scary because it was coming down for quite a ways before the parachutes deployed, but we were still able to recover it successfully.
For our second flight, we, as Ethan said, reset the clay so that the center of gravity was as close as we could get it to the middle of the rocket. And this flight went a lot better. There was still a little bit of deviation in the flight plan, but that is probably due to the Kansas wind, despite waiting for a few weeks before launching and even going out early in the morning. There's still close to 10-mile-per-hour wind here, and so it's hard to get a launch with absolutely no wind, but even then the rocket still stayed on course pretty well. So for the second launch, we also switched our motor. We used a B64 from Estes. This is because we wanted a shorter ejection timing. However, this one, because it was a lower class impulse, it ended up being a lot closer to the ground upon parachute ejection. We were hoping to find either a B42 or a C63. However, at the store that we go to buy rocket engines had neither of those options, and so we settled with the B64.
The next step with this rocket is to try to launch it on our homemade engines. But as we mentioned in our previous motor video, we don't yet have an ejection charge working with those. But once we do get that working, we plan to launch this.
And we will launch on both nozzled and unnozzled variants of our homemade rocket engines.
But yeah, so that'll be in a future video. So thanks for watching.